once you get
But
to that 250.
I assume you can design solutions at multiples of 125 kW for a CNI application. Like you can do a 500 kW system probably
Oh
as
yeah.
well as a
Oh yeah.
megawatt or 375.
Definitely.
I don't know if that's possible.
Yeah,
Um,
and that gets into like you can parallel, right? So
yeah,
you would have, say like this setup right here is the 250 setup. So you'd have this
mhm,
PCS and then a battery cabinet on one side, battery cabinet on the other side, or however you want to configure it.
yeah,
We could add the exact same thing next to it, parallel it all together, and run that all to a single EMS that's, doing the high level control of everything. And we can do that up to 8. We can have 8 of them together um, whenever we're grid tied. Now,
yeah,
there are some nuances there. I will say, whenever you get into the microgrid, that goes down. You can only put 4 in parallel, but that gets into loop currents and more technical type stuff that I don't think we
yeah.
necessarily have time for today. uh,
Makes
but
sense.
the yeah, but to answer your question, you can put quite a few of these together and have it run
Yeah,
that way, depending on how much capacity you need.
yeah. There was also the point about isolation transformers coming into
Yes.
play in these designs. Can you tell
So
us a
that
little bit about that too? And then the
yeah.
480 volts playing into it
hmm
also.
Yeah, which I'll keep it all high level.
Mhm.
But essentially, what I was talking about with that when we spoke previously is whenever you are doing an install where you want to be able to have a microgrid, so where you're independent from the grid itself, um,
Yeah.
you're gonna need an isolation transformer. And the reason for that, so our system and pretty much every other CNI system out there uh, outputs
Mhm.
a 480 delta. So essentially, the output, you know, looks like a triangle, right? If you were to draw it out. With that, there's no neutral point. So you need what we call an isolation transformer, which in most scenarios would be a delta to Y. That way, so the primary side would be delta, the secondary side where your loads are would be a Y. And you do that way you can create a neutral for your loads. So that is a requirement
That
if you're
that
trying
is
to do a
a
microgrid.
that is why it's three phase. Is that kind of like the the difference between three phase and single phase systems in
No,
Resi versus CNI? The
no,
whole
so Resi is a different beast.
uh,
Resi is a split phase. So you can actually you can actually look at it as a Resi output would be like line one and line two, essentially, and then CNI would be line one, line two, line three. So
right.
it's different. It's definitely
Okay.
different.
We don't need to explain it
Technically
all now.
speaking, I mean,
Yeah.
technically speaking, if you look at a
Yeah.
transformer, all it is 3 single phase transformers put together to a common iron core. We can get really deep into it if you want. I don't know how much time we have, but um,
Well,
yeah, split phase
maybe we'll do that
is gonna be
in a
different.
separate conversation. Yeah.
Yeah,
But
let's do that. Let's do
yeah,
that. Yeah.
going back to the topic in hand of you know why an isolation transformer is needed in the more
Mhm.
CNI applications.
Yeah, and the short answer to that question is we're creating a neutral. We're creating a neutral point. Yeah.
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 And so when you look at the market today, like where do you
Mhm.
see most demand and what kind of applications and
Yeah.
geographies and types of customers are demanding your utility and CNI type solutions?
I mean, there's a ton of different scenarios that we see. I'll start with saying that. But some of the really common ones, it's interesting because geographically speaking, things change. Um,
Yeah,
but like we'll take California because we were talking about California earlier. With California, because of NIM 3, we're
yeah,
seeing a lot of people put in batteries there to capture that excess PV. And
yeah,
then so they'll charge essentially the graph would look like, okay, high PV, in the middle of the day. So they're
yeah,
creating enough power that they're getting rid of their loads and then they have excess.